So we have a user schema that captures username, password, and so on and so forth for several that represents the users of our system. We have the user model that allows us to store that information in the database, and we have the service here that is exposing that data model to the rest of the world through some HTTP web service endpoints, right? And we are going to refactor a couple of these endpoints so that instead of using this local array, right, they store it in the database. We already have create and we have find by user, right, by user ID. And we were using it, I believe, for registering when you register a user and when you then go into the profile for that particular user that just registered. Okay, so let's implement the other ones. Let's see, let's start the server and move on to the local host. If we go to assignment, graduate, index, and we go to register, right? This is registering, inserting it into the database. Let's create a new user. Register, Andrew, and that doesn't seem to work. Let's see. Console. Graduate user. Fail. Oh my goodness. Oh, let's see. It looks like it wants to retrieve the user by username. Oh, probably it's checking to see if that user already exists. We don't have that implemented. Let's see. Why would that not be implemented? It's this one, right? Then we have, let's see, respond. So that one returned a 404, and this one is also 404. Do we have the server running? Ah, yes, thank you. I did. I commented it out. Good catch. Let's restart the server. Yeah, this morning I was looking at the undergrad folks and I commented out the graduate one. Thank you. Let's start all over. Let's see. Andy, Andrew, register. Okay. All right, so we got Andrew registered, and notice that we are able to retrieve the user that we just created. If we go to Mongo, if I spell it right, I can show the databases, and the one we're using is this one, right, Summer1. Let's see if we indeed were able to store that information. Show collections, and I probably stored it under graduate user. Let's see, we have Andy in there. We say db dot and then find. And indeed, we have Andrew. Right, we just registered as Andrew. Looks like we have an error here. Probably checking to see if Andrew is there, right? And that query matches the user service endpoint of this one, right? Find all users. That is a function that can check to see the parameters, the query parameters, and depending on that query parameters, it can check to see if the username is taken and whatnot. Okay, so if we go there, there it is, right? It grabs the username and password coming in from the request, from the query, and if it's both, it's going to check both username and password. That's for login, for username and password. Or if it's just a username, then it's going to check to see, it's going to iterate looking for that user by username, or otherwise, it's just going to return all the users, right? It just returns the array of users. Yes, and that's for probably for admin users that want to retrieve all the users. Yes. So let's refactor this one. Let's refactor this one right here. Right. So what we want to be able to do is, ideally, if we have a user model that allows us to find a user by username. Right. Now here we know that we don't have that. User model, but it's often a good idea to start writing an API that you would like from the client's point of view. Who wants to use the API, right? So that it drives the requirements of what other objects might need to implement to fulfill this kind of requirement, right? So find user by username, and we're going to pass the username, and presumably this is going to return a promise from the from a model that hopefully will have the actual user if it finds it. Yes? Okay. Or an error message. And if it finds it, we can just return, or we can just send back the user and then just return. Right? So we don't need this anymore. Okay. Okay, so that's if it finds it, if it finds the user. But I believe we were using the send status 404, right? If we didn't find it, and I believe we have the logic on the client side that if we didn't find it, it was actually okay, right? That username didn't exist. So we can have that logic here as well. We can say, if we have a user, if we have a user, then we're going to return the user. Else, then we can send back a 404. So we could keep exactly the same logic that we had earlier. Just send a status of 404 here. Right, and actually we don't need the return. Okay, so let's see if that works. Actually, let's put a breakpoint here so we can test it. Okay, let's go back and to register again. Let's see who we have as users in here. We have Poe and we have Andrew. Let's try Frank. Register. Okay, so we're in here, and let's put a breakpoint here to see if it finds it. Notice that user comes back as null because Andrew's not in the database. Actually, did we implement find user by username? I'm surprised. Oh, we did. We did implement it, so it's there. I was expecting the server to complain that we don't have a username find user. Oh, okay. We implemented credentials as well. That's great. Okay, so we didn't find user, so it's gonna come in here and respond with a 404, which is going to be interpreted by the client as saying, yep, the username is not taken. But if I go back and I log out and I try to register again using the same Frank, right? It comes back as that we have a user. There it is, the user model coming back from the server, from the database. Notice that it's not a JSON object. Well, it is a JSON object, right? But it's not a trivial JSON object just with username, password, and first name and last name and whatnot. This is actually a managed object, right? It's managed by Mongoose, right? And it has some metadata here, okay, where the actual data is in here. It's in the underscore doc. You see that, the password, the username, the date created is there. See that, right? And this is very similar to what other frameworks do, right? If you've used .NET's entity framework, or if you've used Java's JPA, or if you've used way back when EJBs, the objects that are being sent to the database and come back from the database, right? Those, even though they look like plain old Java objects, they're actually wrapped Java objects, right? With its own APIs that expose your original setters and getters, right? That allow you to interact with the Java bean or the .NET class, right? But it has its own internal mechanisms that allow it to keep track of the status of that object, whether it has been modified. Because this object is very special, right? Because it represents a persistent state object, right? Persistent state piece of data that lives in the database, right? If I ever change something in RAM, ideally I would want also to change that in the database, right? So one is stored in the file system, one is stored in the RAM of the machine, and ideally, right, what I have in RAM is the closest as possible as whatever is really stored in the database. Yes. So obviously there's issues of phantom changes, of people accessing this piece of data inside of a transaction, right? Also, whether the object is locked because I'm reading it, and while I'm reading it, nobody should be able to write it, right? There's other issues that are database issues, right? Also, this object might have references to other objects, yes? Like foreign keys to other objects. And so that's important too. So it's not a plain JSON object, it's a managed object to be able to keep track of all these things. Anyway, we do have an object. We're going to return that object, and the register sees the register object saying, "Oh, Frank is taken. You cannot. I'm not going to let you continue." Okay. Let's see. I think we have an error here. Okay. This was. If we have the function, we have an error here. Okay, where do we show the error message? Sorry, that username is taken. Where do we do that? Oh, there it is. Oh, but it's commented out. Oh, find user by username. Oh, right here, right? And that's where we give the error if we found it. If we don't find it, then we continue. Oh, okay. All right. Okay, so we see that Frank is taken, so we're not going to continue. But now it's checking it against the database as opposed to checking it against the array. Correct? All right. So we have that implemented. Let's now implement the capability of being able to log in as Frank. Right? Notice that if I try to log in as Frank, this is going to come back as that user doesn't exist. There it is. It comes back as a 404. Right, because Frank, even though it's in the database, the original login implementation is still using the old array mechanism. Yes, so we'll need to change that as well. And so that comes in through still find all users, but find all users is going to check against this username. If you have both username and password, this is the logic that's going to run. Yes, okay. So let's refactor it to use a user model find by credentials, right, which we already have implemented. Right, so let's not do this. Instead, let's use a user model find by credentials. There it is. I'm going to pass the username and the password. And this is going to return a promise, which hopefully will have either the user or a not found, right, if we didn't find it. Okay? If we did find a user, right, so same thing as before. It's kind of the same logic as this one, right? If we find the user, we're just going to return the user. If we didn't find it, we're going to return a 404. Okay? All right, so if we restart and we refresh this and we go to Frank and do login. Oops, maybe I got the wrong password. Try that again. There it is. So Frank is in the system, right? It went out to the database to find it. It found it in the database, so it lets me come into my profile. Make sense? Everyone okay? Everyone with me? All right. Let's keep going. Let's now work on perhaps update and unregister.